So Jimmy have some conversation with you yesterday, and I have just found out that we haven't talked about ensemble forecasting in last lectures or tutorials. So here is some content for you. And I found it from this ECMW website. So this figure actually say a lot about what ensemble forecasting is. So you run a number of copies of simulation now in which something is different. And then you will find that they produce different simulation results. Some are quite similar, but some can be quite different. Just like in this figure, you see some plotting on this sphere here that looks more realistic than rectangular map. Then when you do forecasting, this is actually important, because if you only run one copy of NWP simulation, which we call a deterministic model, and then you trust it wholly, then you will make mistake, because there are actually a lot of error in each NWP simulation. So why are there error? Because the evolution of the atmospheric state variables according to the governing equation is actually what we say chaotic. The mathematically that kind of partial differential equation have the property that if there is a tiny difference in the initial condition, then along time integration, the difference will be growing, but they will not diverge exponentially. There are something called strange attractor that sometimes the divergence is bigger, but later the divergence becomes smaller again. So each simulation is not totally unusable, but you cannot trust just one simulation. So you have to have some variety of them, and then for each variety, you run an NWP simulation, and then you check the result of each simulation. So each one is called an ensemble member, and then you can either vary the initial condition, or actually you can vary the model you use or the model options you use. And this paragraph is taken from this document, which I think it is very well written. And then it is also nice to read. It is not as difficult as the paper I have shown you previously. So I think you can start reading it when you feel unsafe what to do if I am told to do a group project of ensemble forecasting. So as you will see, there are 3 kinds of ensemble. One kind is to vary the initial condition. The other kind is to have some ensembles that use more than one model within the ensemble, and we call it multi-model ensemble forecasting. Or you can use the same model but with different combination of physics parameterization schemes, multi-physics ensemble forecasting. Okay, and then you will see, you just Google search and find what people are doing, say in this Wikipedia. And in this example, you will see that this is, you need to expand it and then look into the details. of the description of the figures, you will see that actually it is using different convection parameterization schemes. One use KF scheme, maybe one use this one, and one use WSM3, something like that. So it is also common to use multi-physics ensemble. And if you look into other examples, like this one, this is a multimodal ensemble. So some people will collect forecast results from ECMWF, from Japan, JMA, and from US NCEP, and then put them together to provide more information when you need to do a forecasting. So this is multimodal ensemble. And for CPAS, sorry that we cannot provide multiple initial condition. You just, for forecasting, you just have one choice, which is GFS. So in this project, what you can do for ensemble forecasting, I think, is multi-physics ensemble forecasting. Okay, so I expect some members use different physics parameterization schemes, and you just put them together and see what varying forecasting results they show. And also the mesh can vary. So it is not physics parameterization. You are still using the CPAS model. So this is some kind of changing some component within the model and then put them as different ensemble member. So in your project, I also expect you to try different mesh specification resulting in different unstructured mesh, and then you can think of how to design this variation of models to be as reasonable as you know, and as efficient as you know, and then you just try it in this project, and then you work with your group mate to put them together, and we will see in the coming 2 weeks. And then for an analysis, I will also refer you to read this. So this document is written, is provided by the World Meteorological Organization, WMO, so it is kind of very trustable. It is called the Guidelines on Ensemble Prediction System and Forecasting. It has the introduction telling you why we need to use ensemble forecasting, and then what we need to care about kinds of ensemble. You should read this convective scale EPS section, because if some part of your mesh has grid spacing in this convective scale, then what it can do is pretty much described here, and then what you can expect is also expected here. And how can you use the ensemble forecasting to help you analyze simulation results, so that you combine all information on prediction, and then you make the prediction statement, you role play that you need to make a forecast statement that you will tell the citizens. Okay, so you need to read this. And then for how to analyze the result, this section 4 can tell you, you can take mean, you can analyze the spread, you can do something this document tell you. And then very often you will see people put things together, like making this kind of plots. One kind of plot is called spaghetti charts. So this one is, let me put it here. I captured it out. So it is analyzing 500 hectopascal geopotential height. And then you try to make contour plots of it. And then, you know, contour plots, you have the levels. And then this one show 3 levels. Decimal meter, that means 5,000 something meters. 1 color for each level. And then 1 line for each ensemble member. And then they plot the graph. So in just 1 graph, they will have some impression on the spread on, some ensemble member predict that the shape is like this, but others don't have this shape. And then some ensemble member will have this shape like this, and etc. So they can make analysis. The other type of plotting that you usually see is called postage stamp maps. So for each ensemble member, they just plot like what we have done before, and then 50 ensemble members, they just make each plotting to be small and then put them together, and then let the color show what is eye-catching, what feature are different, and then they try to analyze. So these are some techniques that you may read from this document, and then we try to learn together, and then let's see what we can come up in your project. And then for typhoon or for hurricanes, people will plot the track coming out from each ensemble member and then put them together. And then you will see the spread of the tracks. And that will give you some information of what you expect, what is possible to be the outcome of the weather.